Hi, my name is Adrienne Young, and I'm the Director of Design Technology at Public Architecture and Design. Today, I'd like to talk about BIM, or Building Information Modeling, the practice of tracking digital information on all of the building's assets. BIM is sort of the next stage of evolution of the architecture practice, starting from originally hand-drawn plans and building sections and moving through computer-assisted design, and then finally to 3D modeling. The idea behind BIM is that, one, it can contain all the information related to the building itself, whereas previously we would have the 2D plans and also additional specifications about the products that were being ordered, and then the operator would also have their own operations and maintenance manual that with BIM can be actually linked into one common data portal. Once you have the BIM model with all the data entered into it, you can hand that off to the owner-operator, and the owner-operator would then be able to look in that model, identify different equipment. They would be able to locate it in the building, and they could then track the maintenance history of it. They could track when it's expected to need replacement or repair. They can basically just store all the information that would previously have been in a separate filing system or PDF manual, and everything would be able to be sort of tied into this one BIM model. So, Vienna House, one of the mandates of the project was to use prefab construction methods. BIM was an integral part of that process. We would just model walls and floors. The model could then be passed on to the trades, and they could take that spatial information and then break it down into their respective parts that they're manufacturing. So, for example, we had wall panels that were fabricated in a warehouse. So they took our model and then built their wall panels into that model, each individual panel, and then constructed those in the factory. Then they tagged them with exactly where they would go once they arrived on site. So then they could just be sort of puzzle pieced back together. We've seen the quick assembly of all the prefab components from the CLT panels to the wall panels, and the contractor has set up sort of a QR code to scan so they know exactly in the building where they are. The prefab trades, I think, benefited the most from the BIM process. The main ones on our project were CLT, or cross-laminated timber, wall panels, structural steel, and the prefabricated balconies. And each of those trades works in 3D before they start their manufacturing process. And if we hadn't provided them with the 3D BIM model, that might have added additional months of time onto the work that they did and additional costs to the project as well. An important part of the BIM process is clash detection before you arrive on site. In a non-BIM project, the mechanical, electrical, plumbing consultants would be just basically showing their drawings in 2D. So they would draw them where they need to go from one place to the other, but they wouldn't take into account the elevation of those elements. And so on site, they could suddenly find out that there's not enough space to have the steel beam as well as those services. But with a BIM model, you can easily see, okay, this pipe is running right into the steel beam, and it can't. So we either need to drop the ceiling so that there's space for both of them, or find another way to mitigate the issue. BIM is quite a powerful tool, but sometimes there is resistance from the client to using it. I think the main reason would be costs. There is additional upfront costs with the goal of saving more money during the construction phase. And so some clients, I guess, either don't have the experience to know that that is the case, or don't have the upfront costs to invest in BIM in that way. Another reason that clients might not use it right now is that it's a new technology that in Canada hasn't really gained a foothold yet. In other countries, they do have a standardized BIM practice that designers and clients and contractors are expected to use. But in Canada, we don't have that because it's new and maybe scary. It just sometimes doesn't happen. I think the most important thing to really get BIM going in the AEC industry is to have a top-down approach where there are standards that are implemented either at the federal or provincial level that apply to all projects, and that would be basic data requirements, standardization of that data. Here in March 2025, we've topped out the building and are currently in the process of closing it in. So that's adding cladding to the walls, putting in the windows, and putting on the roof so that the building is watertight, and then the interior works can begin. So that would be adding gypsum board drywalling, putting on the floor finishes, painting, etc. They're also starting to install the steel in the courtyard. So that would be the staircases, the columns that are holding up the walkways, and also the attachments to the walls for the walkways. Vienna House has definitely been a learning experience for me in particular, as well as I think everyone involved in the project. It's great to see it all coming together on site, knowing the parts that are coming up and being able to spot them in the 3D model and be like, this is what it should look like, double checking on site, and just having everyone working on this off of the same goal and the same idea. I'm excited for it to keep coming together. Vienna House was sort of a research project in certain ways where we experimented with a lot of different new processes and new construction and new thinking around the design of the building. And I'm hoping that we can take a lot of the lessons that we learned from the Vienna House project to other projects we have in the office. We work on a lot of multifamily housing, but any project could use prefab, any project could be passive house, any project could use BIM and benefit from it.